Everyone's group data from this morning compiled into Excel. I quickly realized that after you guys left, Excel is similar to regression, just not very good at making histograms, and therefore a statistical package like Minitab is much better suited for producing a graph like a histogram. Now I know that not everyone has easy access to Minitab, and therefore I'm going to create this screencast that shows the process of making this graph. It'll be presented to you there in the email, the graph and all. I wanted to do it in a screencast, however, so that it was almost like we were doing it in class, and so I'm not just giving you the graph, you can actually see how it's done. So this is the data just as it was given to me on your guys' data sheets with our tree species, the distance to the same species neighbor, and the distance to the nearest neighbor in general. The first thing we'll do is we'll copy and paste all of this data into Minitab. So I'm using Minitab Express, so similar to what we were using last week. We'll paste that in. We can adjust these headings to fit all of the characters. And then we simply go to Graphs, Histogram. Now the first thing we're going to investigate is what is the dispersion of trees in the forest as a whole, regardless of species. So we're not really interested in distance to the same species neighbor. We're interested in this case to just general distance to general neighbor. So we'll go just to a simple histogram with a single y variable. Again, this is now distance to nearest neighbor in general. We'll double click that. And now we have a histogram. So the way a histogram works is that you've got all of your distance to nearest neighbors listed out here. Here being the minimum and the maximum over on the right. The frequency is then the number of times that specific distance in meters was recorded. So for this first example, for White Oak, in this first data point was a 1.38 distance to nearest neighbor, 1.38 meters. Now if there was 15 1.38 measurements, then we would see 1.38 here in this section of the graph with the frequency of around 15. So that's the way this histogram is laid out, and now we can correlate this based on what I told you in lab. The general shape of this histogram can give us insight into whether it's aggregated, random, or regular. Now we might think that this is random because it has this sort of Poisson distribution shape. There is a quantitative way to actually figure out whether it's random, aggregated, or regular. So the first thing we'll do is we'll get this nice neat looking graph back into Excel or Word or whatever we're going to be using. So we'll paste that in, and like I said, I'll provide this for you. Then we're going to go ahead and look at these summary statistics here that Minitab also provides. So we'll first copy and paste this into Excel. And then we're going to go back to the lab guide actually. So in this section of the lab guide, when it's talking about the different frequency distributions, this paragraph here is incredibly important. It talks about this variance to mean ratio, which we can acquire from our summary statistics. And if this ratio, variance to mean, which is sometimes known as an index of dispersion, is around 1, then that is a random distribution. If that variance to mean ratio is greater than 1 significantly, then we would say that it is a aggregated distribution, and we would say that it is a regular distribution when that VMR is significantly less than 1. So just to show you index of dispersion, dispersion is equal to the variance over the mean. So this is that VMR, variance to mean ratio. So if we go back to our summary statistics, it does give us a standard deviation. Obviously, standard deviation is simply the square root of variance. So we need to go ahead and create a variance column, which is going to be simply equals our standard deviation squared. We can also make a column called VMR, which will stand for variance to mean ratio. And we could say dispersion type. Get it all laid out. So this is simply going to be equal to, just as I showed in that equation, the variance over the mean. We get a number that's pretty close to 1, but I would not say it is around 1. I would say that is relatively significantly less than 1 and therefore this is actually a regular dispersion pattern. So while at first glance it does look like it's a random distribution, it is regular, probably because of these offset variables. It is pretty close to random. Like I said, if it's around 1, some could argue that this was a random distribution, but I would say that that's relatively significantly less than 1, and therefore is a regular distribution type. So that's an example of how you would explore the dispersion pattern of the forest as a whole, not including any specific species. Now if we go back to Minitab, we can actually look at species-specific distance to neighbors. So we'll go ahead and back to graphs and histogram. This time we'll do groups. So you could have different histograms for each of your species, but that would be a little bit convoluted, and Minitab is nice and you can get all histograms in one figure simply clicking by groups. The y variable this time will be the distance to the same species neighbor, because we're interested to see how each one of these species aggregates within the forest as a whole. And then the group variable will be the tree species name. So now you see a histogram of each of these different species. So for Emily's group, they found beech, black cherry, black oak, sassafras, sugar maple, white oak, and white pine. Now some of these don't look very useful at all because there was only maybe one data point. So for example, sassafras was a particularly rare tree in that forest, and you can't find the distribution if you only have one tree, so that's going to be a negligible factor. So we'll go ahead and copy this graph out as well, and this will give us our species-specific data. And just as we did before, we'll look at those summary statistics. Now this is really nice because it gives you by the species. And obviously, where n was 1, there is no standard deviation, right? So there's just an asterisk there because these points, white pine and sassafras, we cannot describe the distribution pattern if there was only one tree. So we'll go ahead and copy this in to Excel, and we paste it below. Again, like before, we need to solve for the variance. Also the variance to mean ratio, and we can actually look again at the dispersion type. So variance again was going to be the standard deviation squared, and we can use Excel here to autofill. Now we're going to get a null value here because again there's no standard deviation, so we can just put an asterisk in just as they did in Minitab. Now the VMR again is going to be equal to the variance over the mean. And we can drag that down. We're going to be expecting null values again for these two, which is totally fine. And now we can start to explore. Now this is pretty close to 1. So the beech tree I would say is random. This is black cherry is significantly over 1, therefore it is aggregated. Black oak is much greater than 1, again aggregated. Sugar maple, that's again pretty close to random, but I would say that 0.7 is probably the cutoff, so we'll go ahead and say that that is a regular distribution, and white oak being much less than 1, nearly half of 1 is also regular. So if you need information as to what each of these kind of code for, just go back to the lab guide, and it talks about, again, if it is equal to 1, it's a random distribution. If the frequency or variance to mean ratio is greater than 1, we're at an aggregated distribution. And finally, if it is less than 1, it is an even or regular distribution. So now we have this really neat set of data where we can visualize these histograms and also have some quantitative evidence as to which type of dispersion each of these are. So I will provide you with these graphs and these summary statistics just as you see here in this Excel format, so you can copy and paste these into your Word document as needed. I just wanted to show you a screencast so that everyone maybe feels a little bit more comfortable about the process rather than me just handing you them. I don't think that would be the right thing to do. So this will be more like we did it in class, so I hope everyone gets something out of this video. Please let me know if you have any questions, of course. So I'll end it there. I will go ahead and provide the same type of data for Robert's group, and it'll be interesting to see what the differences were between Emily and Robert's group based on the fact that one group was kind of down in that ravine where Robert's group was up on the ridge. So these are some really nice figures and some great data. So nice work today. Thanks for bearing the cold, and have a great weekend.